Here's the quick way to find the horizontal asymptotes of rational functions. Warning, in this video I'm just going to show you the 4 simple tricks for finding horizontal asymptotes. But if you really want to understand why these work, you should watch my other video on how to find them using limits at infinity. Anyways, when you have a rational function, which is just a fraction with polynomials on the top and bottom, the key to finding horizontal asymptotes is to compare the highest effective power of x on the top with the highest effective power of x on the bottom. In this case, the top has a power of 2 and the bottom has a power of 3. And when the top power is smaller than the bottom power, this means that there is a horizontal asymptote at y equals 0. The next type of horizontal asymptote occurs when the highest effective power of x on the top is equal to the highest effective power of x on the bottom. Looking at this function, the highest power on both the top and bottom is 4. So now what we're going to do is look at the leading coefficient, or number in front of the highest power of each x, and then we are going to take those numbers and divide the top one by the bottom one. This gives us 3 divided by -6, which simplifies to -1/2. And so now we can say that there is a horizontal asymptote at y equals -1/2. The third type of asymptote occurs when the highest effective power of x on the top is exactly 1 more than the highest effective power of x on the bottom. In this example, the power on the top is 2, and the power on the bottom is 1. When this happens, you get what is called a slant asymptote, which basically means that the function tries to approach a line. If we want to find out the equation of this slant asymptote line, all you have to do is divide the top and bottom using polynomial long division. And when you get your result, just ignore the remainder. In this case, we get 2x minus 4 with 12 divided by x plus 2 as our remainder. So we can say there is a slant asymptote at y equals 2x minus 4. Now let's look at the last type of horizontal asymptote. You may be wondering why I keep saying the highest effective power of x. Well, that's because you can't just look for the biggest number in the exponent. Take this function, for example. At first glance, it would seem that the highest effective power of x on both the top and bottom is 4, since that's the biggest number we see in the exponents. However, there is a square root on the bottom x to the 4th, which will end up cutting its effective power to only 2. This is because square roots are the same as raising a number to the 1/2. And if we remember our exponent rules, raising a power to a power multiplies the powers together. So now the highest effective power on the top is bigger than the highest effective power on the bottom by more than 1. And when this happens, it means there are no horizontal asymptotes. So to sum things up, when finding the horizontal asymptotes of rational functions, just look at the highest effective power of x on the top versus the bottom. If the top is less than the bottom, then there is a horizontal asymptote at y equals 0. If the top is equal to the bottom, then there is a non-zero horizontal asymptote that you get by dividing the leading coefficient of the top by the leading coefficient of the bottom. If the top is 1 bigger than the bottom, then there's a slant asymptote you can find using polynomial long division. And finally, if the top is more than 1 power bigger than the bottom, then there are no horizontal asymptotes. And there you have it. That's the quick way to find horizontal asymptotes.
Nice!